So let's move now to a different situation when we have an object that is in a horizontal surface and the mass of the object is, let's say, 15 kilograms, and we have a force applied that is parallel with the surface, and it is about 20 newtons. And as a result of this, the object is moving in the east direction for 10 meters. So what we are dealing here with is a frictionless surface. Now let's start with the free body diagram, because what we are looking for here is what is force of gravity, what is force normal, what is force net, let's say what is force net, what is the acceleration of the object, and then what is the work done by force of gravity, what is the work done by force normal, what is the work done by force applied, what is the work net that the object is experiencing. Okay, so what do we do since we are dealing with forces? We always draw the free body diagram. So the free body diagram in this situation will be force of gravity that is always going down, and then perpendicular to the surface is force normal, and then we have a force applied that is in the east direction. Let's say now what are the values. So for force applied we have 20 newtons. For force of gravity we have a mass of 15, so 15 times 9.81 will be 147.15. And let's figure out what is force normal. Now, as I mentioned yesterday, do not assume that force normal is always equal to force of gravity. The reason that we complete the table and we go through the hustle of completing the table, which I hope that now is not a hustle anymore, is fun. The reason that we do this is to not think specific cases. What is happening when? What is happening when? We just complete the table and we solve based on the equations that we get from the table. Okay, after we are done with all the forces, then we say what is force net. So now the horizontal component of force applied will be positive 20. The vertical will be 0. The vertical component of force of gravity, or the horizontal component of force of gravity, is 0. And the vertical component is negative 147.15. The horizontal component of force normal is 0, and the vertical component is positive force normal. The object is moving in the east direction, so this is the direction of the displacement. So then will be positive 15, that is the mass of the object, times acceleration, and the object is not moving in the vertical direction. It's the same thing as we did when we were doing or solving problems on dynamics. Okay. From the horizontal, what we have is 20 is equal to 15, it's positive 20 is equal to positive 15 times acceleration. From the vertical, what we have is negative 147.15 plus force normal equals to 0. From here, we find that acceleration is 20 divided by 15 is 1.33 meters per second squared. And from here, we find that force normal is equal to 147.15 newtons. Okay. Now, force net, we do know what it is. It is whatever is the acceleration times the mass, or is positive 20 newtons. So now we have three things that the problem or the question is asking us for. Let's move on to finding the work that each of those forces have completed. So now, the work done by force of gravity will be the component of force of gravity along the displacement times the displacement. We said that the displacement is 10 meters. So the component of force of gravity, so here is the displacement, that is 10 meters. And here is the force of gravity. The component of the displacement along the component of force of gravity along the displacement will be 0 times 10 is equal to 0 joules. Let's move to the work done by force normal. So it is the component of this force along the displacement times displacement. So in this situation, what do we have is displacement is this way, 10 meters, and then force normal is up. So the component of the force normal along the displacement is equal to 0 times 10 is equal to 0 joules. And again, we in physics, we do not work with, or we do not function with cases. Oh, in this case is this, in this case is this. We have a principle. On this case, the principle is find the component of the force along the displacement and multiply it by displacement. And whatever math is telling us, that will be the value. Okay? And then the work done by force applied will be the component of force applied along the displacement times displacement. In this situation, what do we have is something like this. Displacement being 10 meters and force applied is this one here, which was 20, I think. Force applied is 20. So the component of the force, this force along the displacement is the force itself. So will be 20, positive 20 times 10 equals to positive 200 joules. And now when we are finding force net, what we are doing, there is no other forces here. When we are finding force net, what we are doing is we are adding the work done by all the forces. Work done by force applied. This will be 0 plus 0 plus positive 200 equals to positive 200 joules. You can check now with the force net that we found. So you can say that work net is equal to force net component along the displacement times the displacement itself. The force net is on that direction because this is where the object is moving. So it will be positive 20 times 10. It should be actually positive 10. Positive and positive is positive. So 200 joules. And this is how you check that your work is correct. Question. Okay, so let's continue now with a different situational diagram. So we have an object here that is with, let's stick with 15 again, just for simplicity. And we have a force that is, a force applied that is 20 newtons at an angle with the horizontal of 30 degrees. And again, the object is in a frictionless surface, so friction is 0. What we are looking for here is we are looking what is force of gravity, what is force normal, what is force net, what is acceleration. And this is pure dynamic question. And then what is the work done by force of gravity? What is the work done by force normal? What is the work done by force applied? What is the work net that the object is experiencing? Okay, since we are looking for forces, this is what you will see on the quiz, a similar situation. Now, since we are looking for forces, what we do is we draw the free body diagram. We start with force of gravity. That is 147.15 newtons. We have a horizontal surface perpendicular to the surface. We have a force normal. I should not do this. We have a force normal. That is this way. And then we have a force applied that is on this direction at 30 degrees. See here, even if you have something like this on the final, let's say, and they are asking you which one is the correct free body diagram of the object. So you may have this as the situation, and then you may have this as the other option. So force normal. The reason that the correct one is this one here is because force normal is not almost the same as the force of gravity that we have here. Because we will see based on the calculation that it is not. You have a component of this force applied, and since they are with the same direction, on the vertical direction, and they are both going up, they have to add together to give you what is force of gravity. But if you are wondering why and how, you will see now through the calculations that force normal is not what we have, even though that we have the same mass and the same horizontal surface. Force normal is not now 147.15. Okay, let's draw the table of components. So this is horizontal, vertical. We start with force applied, and then force of gravity, force normal, and we end up with force net. So for force applied, the horizontal component will be whatever is 20 times cosine 30, which is positive 17.3, and the vertical component is positive 10 times 20 times sine 30. Force of gravity on the horizontal is 0, on the vertical is negative 147.15. 0 on the horizontal for force normal, force normal in the vertical. Then we have positive 15, that is the mass times acceleration, and 0 on the vertical. From the horizontal, what we have is positive 17.3 is equal to positive 15.0 times acceleration. From here, we find that acceleration is 1.15 meters per second squared. So we found one of the things that we were asked for. And from the vertical, what do we have? See now what it is. Plus 10. So we don't even think, we just solve the equation. Minus 147.15 plus force normal equals to 0. So from here we find that force normal is 137.15 newtons. And see now, from the previous question where the force normal was 147.15, you see the math tells us that actually is not the equal to force of gravity. Is this clear? For the work done by force of gravity will be whatever is the component of force of gravity along the displacement times the displacement. I believe that the displacement is still 10. Yes. Yeah, displacement is still 10. Then we'll go 0 times 10 because we are saving the same kind of situation, 0 joules. The work done by force normal will be the component of force normal along the displacement times the displacement. 0 times 10 is equal to 0 joules. And then the work done by force applied is the component of force applied along the displacement times the displacement. And the table actually gives us what it is. So it's positive 17.3 times positive 10 equals to positive 173 joules. And the work net will be the sum of the works that all of those forces have done to the object. Force applied. So 0 plus 0 plus positive 173 equals to positive 173 joules. The way that we check it is by looking at what is force net. So force net is mass times acceleration, which in our situation will be 15 times 1.3, I think. No, 1.1. 1.115, and this will be 17.3 newtons. So work net, like everything that we have said now, is the component of force net along the displacement times displacement. Force net is in this direction. It's along the acceleration. Displacement is in this direction. So we are on the situation that those are equal to each other. So this will be positive 17.3 times positive 10 equals to positive 173 joules, which should be the same number as what we found when we added arithmetically, actually algebraically, the value of the work. Questions? So we'll deal with similar situation, but now we will add a friction. So we are in a horizontal surface. We have an object with mass 15 kilogram, and we have a force that is like this with a magnitude of, let's say, 100 newtons, or 200, let's make it 200 newtons. at an angle now, we'll make the angle with the vertical as 50 degrees. Okay, so what we are, displacement here as a result of this, well, let's say that the object is not moving. So displacement is equal to 0. The object is not moving, even though that we apply this force, the object is still at rest. So now we will find what is force of gravity, what is force normal, what is force of friction, and then what is work done by force of gravity. We can say even here force net, and why not acceleration. What is work done by force normal? What is work done by force of friction? What is work net? Work done by force applied. What is work net? Okay, we are looking for forces. That means that we will start with the free body diagram. So the object of our interest is represented by a dot. We have a force of gravity that is 147.15 newtons. So this is the benefit of keeping the same numbers. Then we have a force applied that is 200 newtons at an angle of 50 degrees with the vertical. Then we have a force normal that is like this, less than what we see in force of gravity, and we have a force of friction. How do we know that we have a force of friction? Even though that we are applying a force, still the object is at rest. And this may be a bit not the coefficient, so we will just find the force of friction, not the coefficient. Okay, so now let's build the table. Horizontal, vertical, force applied, force of gravity, force normal, force of friction, and then we end up with force net. Horizontal component of force applied. So horizontal component of force applied is this one here, this vector here, which is sine. So 200 times sine 50 is positive 153.2. Now, you may say that, Miss, can I use the angle 40 here? Yes, you can. But we have said that when we are finding components, from the tip of the vector, we draw a right angle triangle that includes the given angle. You may find that angle, you may use that angle 40. The vertical component of force applied will be related to cosine, so 200 times cosine 50, and it is positive 128.6. Horizontal of force of gravity 0, vertical negative 147.15. Force normal on the horizontal 0, on the vertical is positive force normal. Force of friction on the horizontal is negative force of friction, and the vertical is 0. And now the object is at rest. That means that the acceleration is equal to 0, which gives us, based on the second law of Newton, force net 0. Now what do we have here is from the horizontal, we have force of friction is equal to 153.2 newtons. From the vertical, what do we have is force normal. See how small it is now, 147.15. minus 128.6. And it is only 18.55 newtons. So we found 2. The acceleration is equal to 0 since the object is at rest. Force net is equal to 0. So we found those quantities that the question is asking us for. Okay, let's move now to work. So work that is done by force of gravity is the component of force of gravity along the displacement times the displacement. In this case is 0. So 0 times the 0 equals to 0 joules. Force normal is the same deal. 0 times 0 is equal to 0 joules. Work done by force of friction is negative, or the component of the force of friction along the displacement, so will be negative 153.2 times 0 equals to 0 joules. Make sense? The work done by force applied is the component of force applied along the displacement times the displacement, so 153.2 positive times 0 equals to 0 joules. Then work net will be the sum of all the work. So 0 plus 0 plus 0 plus 0 equals to 0 joules. You can verify this by saying work net is the component of force net along the displacement times 0. 0 times 0 is equal to 0 joules. Does this make sense? Let's stick with the horizontal surface. And now we have an object that, as a result of the force applied, mass is again 15 kilograms. And then we have a force applied here that is with a magnitude of 200 newtons at an angle of 20 degrees with the horizontal. But as a result of this force, the object is moving with constant velocity. This is the same as saying that the acceleration is equal to 0, which based on the second law of Newton tells us that force net is equal to 0. On this question, what we are finding is what is force of gravity, what is force normal, what is force of friction, and then we said what is force net. And then we'll move to what is the work done by force of gravity, work done by force normal, work done by force applied, and what is work net. What can you say about work net without doing any calculations? It is 0 because the force net is equal to 0. And just to make it a bit more complicated, we can say that the displacement is 10 meters in the east direction. Okay, so let's start with a free body diagram. So we'll have force of gravity. We'll have the surface. We'll have the given force applied as 200 newtons at 20 degrees with the horizontal. And then we will have force normal. Notice here again, I'm making a force normal, a vector that is smaller than the force of gravity. And the calculations will tell us that this is the true one. So now let's do the horizontal and the vertical component of all the forces. Force applied, force of gravity, force normal, force of friction, and then we finish with force net. So horizontal component of force applied will be related to cosine. Cosine 20 times 200 is positive 187.9. And the vertical component is related to sine, so will be positive 68.4. Horizontal of Fg is 0, negative 147.15, 0, positive Fm, negative force of friction, 0, and since the object is moving with constant velocity, acceleration is 0, force net is 0. From the horizontal, what do we find is force of friction is equal to 187.9 newtons. So we found what is force of friction. From the vertical, what we have is force normal is equal to 147.15 minus 68.4 equal to 78.75 newtons. Okay, so we found this, we found this, we found this, and now let's find what is work done by force of gravity, and it is 0. What is the work done? We cleared it. Y is 0. What is the work done by force applied? Will be positive 187.9 times positive 10 equals to positive 1879 joules. Work done by force of friction will be negative because it is on the opposite direction of the displacement. 187.9 times positive 10 equals to negative 187.9 joules, which tells us that work net is equal to 0 plus 0 plus positive 1879 plus negative 1879 equals to 0 joules, which is what we said that the work net will be since force net is equal to 0. Now we'll see a situation when the object is still in the horizontal surface. Mass is equal to 15 kilograms. And now we have a force applied that is on this direction. So force applied is, let's say, is 115 newtons at 25 degrees. And we have a coefficient of the friction 0.20. So on this situation, what we are looking for is what is force of gravity, what is force normal, what is force of friction, and the object is moving with an acceleration of 2.0 meters per second squared, and during the time interval, it is, well, let's make this a kinematics as well. So acceleration is 2.0 meters per second squared, and it's starting from rest, and it is moving for a time of 3.50 seconds. Okay, so we are looking for force of gravity, force normal, force of friction, displacement, And then work done by force of gravity, work done by force normal, work done by force of friction, work done by force applied, work net. Let's add here force net as well. Okay, so this is kinematics and dynamics and work and energy. And when I said yesterday that you can actually solve any problem using work and energy principle and work concept, I was not joking. So now we have a force of gravity that goes down with a magnitude of 147.15 newtons. We have a force applied that is with a magnitude of 115 newtons. 115 newtons at 25 degrees. We have a force normal that is going up. Notice here again, that is smaller in magnitude than force of gravity. And then we have a force of friction. So let's start finding forces first. Building the table, horizontal, vertical, force applied, force of gravity, force normal, force of friction, and then we end up with force net. So horizontal component of force applied will be 150 times cosine 25, and it is positive 135.9. And the vertical component is 150 times sine 25, so it will be positive 63.4. Force of gravity in the horizontal 0, in the vertical negative 147.15. Force normal 0, positive force normal. Force of friction, negative force of friction, and 0. Force net will be can we leave acceleration out? Let's leave acceleration out. We don't know what acceleration is. We just know that the object starts from rest, scrap acceleration. We just know that, because it may not work out. We just know that it starts from rest and it moves at 3.50 seconds. Okay, is it clear? So this will be positive 15 times acceleration, and here will be 0. From the horizontal, what do we have is 135.9 plus negative, which means negative force of friction is equal to 15 times acceleration. And from the vertical, what we have is force normal is 147.15 minus 63.4 equals to 83.75 newtons. Knowing the fact that force of friction is coefficient of the friction times force normal, and knowing that the coefficient of the friction given here is 0.2, 0.2 times 83.75, force of friction will be 83.75, no, 0.2 times 83.75 is 16.56 75 newtons. So now the question was asking for force of gravity. We do have it. Force normal is 83.75. Force of friction is 16.75. And then let's find force net. So from the horizontal, what do we have is 135.9 minus 16.75 is force net, or mass times acceleration. So 135.9 minus 16.75. So force net will be 119.15. And then from here, we can find that acceleration is force net divided by mass is 7.94 meters per second squared. Is it clear? Now, in order to find the displacement, what we will do is we will use kinematics equations. So what is given here is that the object is starting from rest and it is moving at a time of 3.50 seconds. And now from the previous work, we found that acceleration is 7.94 meters per second squared. So now we are looking for displacement. And then based on the kinematics equations, we can say that this is the equation that we will use is V initial time plus 1/2 acceleration times square. V initial is equal to 0, so will be 1/2 times acceleration times t squared, or 1/2 times 7.94 times time is given as 3.50 squared. So displacement will be 0.5 times 7.94 times 3.5 squared. It's 48.63 meters. Clear? Now that we know everything, then we can calculate the work done by force of gravity, 0. The work done by force normal, 0. The work done by force applied will be whatever is the component of force applied along the displacement, which is the table is telling us, 135.9, positive 135.9, times the displacement that we just found, positive 48.63. So 137.9 times 48.63 is equal to positive 6608. We can say 0.9 joules. Is it clear? And now when we are finding the work done by force of friction will be the component of force of friction along the displacement times the displacement. Now the component of the force of friction along the displacement is the negative magnitude of the force of friction, so negative 16.75, and here the table tells us everything, plus times positive 48.63. So now 16.75 times 48.70 or 63 is negative 18. We can say 5. Okay, so this is one work, this is the second one, third one, fourth one. And now work net will be the work done by all the forces that the object is experiencing. Force normal, force work done by force applied, work done by force applied, and work done by force of friction. So it will be 0 plus 0 plus positive 6609 plus negative 815. So work net is 6609 minus 815 is 5.5794 joules, or you can say kilojoules. 1, 2, 3, 5.79 kilojoules, or if it is to 2 sigdigs, then 5.88 kilojoules. Depend what they are asking you for. Is it so? If we have an incline at, let's say, 40-degree angle, and we have an object here that starts at the rest with mass of, let's say, 20 kilograms now, and we have a coefficient of the friction of 0.10. Let's figure out everything. Let's find what is force of gravity, what is force normal, what is force of friction, what is acceleration, what is work done by force of gravity, work done by force normal, work done by force of friction, work net. And if we think of anything else, then we can do it. So it is starting from rest. Now let's draw the free body diagram. So we start with the object of our interest, represented by a dot. We have force of gravity, which now is 20 times 9.81, and it is 196.2 newtons. We have an incline with a 40-degree angle. Perpendicular to the incline, we have a force normal. And then let's break it down, force of gravity into 2. This angle is 40. It's exactly what we have said and done in dynamics. So this is the vertical component of force of gravity, and this is the horizontal component of force of gravity. And then we have a force of friction that is going like this. Okay, so we'll start with a table. What we have said in the dynamics, we rotate the axis. So now we have a new horizontal and a new vertical axis. We rotate them to be along the surface. So we have the rotated horizontal and the rotated vertical axis. So we'll start with, there is no force applied. Force of gravity, force normal, force of friction. And now that we are done, we write what is force net. So force of gravity in the horizontal will be positive. So it's 196.2 times sine 40. So it is positive 126.1. And the vertical is 196.2 times cosine 40. And it is negative 150.3. The horizontal force normal is 0. The vertical is positive force normal. Force of friction on the horizontal is negative force of friction. The vertical is 0. This will be positive 20 times acceleration, and here is 0. Is this clear? From the horizontal, what do we have is positive 126.1 minus force of friction is equal to positive 20 times acceleration. We don't start with this equation because we have two variables, force of friction and acceleration. From the vertical, what do we have is force normal is equal to 150.3 newtons. So now we know what is force of gravity, and we know what is force normal, 150. Based on the fact that we have an acceleration of 0.10, we can find force of friction as coefficient of the friction times force normal. So 0.10 times 150.3. Therefore, force of friction will be 15.03 newtons. Correct? Now, bringing up the horizontal equation will be positive 126.1 minus 15.03 equals to positive 20 times acceleration. So 126.1 minus 15.03 divided by 20 is acceleration is equal to 5.55 meters per second squared. It's good if you do those calculations on your own so that you can keep me checked. Is this correct? Is this understood? Now that we have everything that we need, we can find the work done by force of gravity. Will be the component of force of gravity along the displacement times the displacement. We'll say that displacement is 1 meter, just for simplicity. So on the case that they give you the time, then you will use kinematics equation to find the displacement. But on this case, I'm just giving it because we did a similar question with the displacement, finding the displacement using kinematics equation. So now let's see this. The displacement is on this direction, 1 meter. Force of gravity is on this direction. Okay, creating a 40-degree angle with the vertical axis rotated. So the component of the force along the displacement is this one here. So see guys, everything ties up. Everything, the table that we have done, even here can be used. Okay, so and where can we find this? We have it here. Is this value. So this will be positive 126.1 times positive 1 meter. Please don't tell me. Positive 1 meter. So it is 126.1 positive times positive 1 meter. And this will be positive 126.1 joules. This is the work done by force of gravity. Okay, the work done by force normal will be the component of force normal along the displacement times the displacement. And see what we have in this situation. So we have a displacement on this direction and a force normal perpendicular to the direction. So the component of it is equal to 0 times positive 1 meter equals to 0 joules. Agree? And then we have work done by force of friction will be the component of force of friction along the displacement times the displacement. And see what do we have on that situation. We have a horizontal surface, a displacement, or not horizontal, incline. The displacement is on this direction, while force of friction is on this direction with a magnitude of 15.03 newtons. So now it will be negative 15.03 times positive 1 meter. So therefore, the work done by force of friction will be negative 15.03 joules. Force net or work net will be the sum of all the works. So work net will be positive 126.1 plus 0 plus negative 15.03. So 126.1 minus 15.03 equals to positive 111.07 joules. You can check it by saying what is force net times displacement. I bet your force net will be 111.07 newtons. Is this clear?